Jamen, velkommen til den intelligente elmåler. Et koncept, som vi skulle vise kunne eksistere og bruges. Det gik i sin enkelhed ud på, at vi skulle forsøge at sammen med et lavningsbyggeri at få etableret en intelligent elmåler, der kunne styre og fordele energien i huset. Det var som udgangspunktet, vi søgte penge på. Det gjorde vi sammen med IKT, ingeniøruddannelsen, og det gjorde vi så sammen med vores partner, Andrei fra Toga Elteknik. Og det var et videnscenter, der sendte ansøgningen. Og så var vi så heldige, at vi fik et par studerende med fra uddannelsen, ICT, godt nok fra internationalt, så det bliver på engelsk, men de præsenterer projektet her. Så det synes jeg, vi skal gå over til, at Tomas og Andrei, de præsenterer her konceptet. Værsgo.
So, hello, I'm Andrei. I'm studying ICT engineering. So this would be our final project, and it's a accumulation of all the knowledge we have gathered from the last semesters, because this involves a lot of technologies. It involves working with hardware as much as with internet services and all the technologies that we have studied over the years, plus some other research that we had to do. The point of this is mostly to release the grid. So the electrical grid is very charged during the night because there's not so much usage of the electricity. So we plan on storing it over the day, or when there is excess energy from the night, for example, when windmills are running and there's not so much consumption. So we can store it in two forms: in heat energy, which is it's pretty efficient to store it as heat, but you can't release it back to the grid. And also in electrical form inside the battery, so we can both release it to the grid if it is needed, or pass it on to other electrical devices around the house. This can also then be extended to an industrial use, when an electrical company can use this system to store excess energy whenever it feels the need for it in people's houses. So this can benefit the user because he's going to save some money due to this, and also the producers of renewable energy, because they can run it 100%. And then if we're going to take the industrial approach, then we're going to target also the industrial needs of the electricity producers. This, in the end, we might also want to attach to it a user view, so that a user can log into any device and check the state of its house, how it's doing, what can it do, what has it done until now, and also since we plan on having it as a web service, then anything can be connected to it and control, and we can have a lot of interaction with this application.
Okay, well, now about the connectivity with the user. You as the owner of the house would probably like to know how much money you're saving right now, how much power is your house using right now, how much power you have in storage for next few days. So how to achieve this? Imagine that you are on the go, as a lot of people are quite busy during the day. What you can do, you can take a glimpse of how your house is doing directly, let's say on your mobile phone. It can be, mostly this will be used on smartphones. Also, you can log in remotely and see how your house is doing from any web browser. Also, what you can do, you have pretty much all the devices. You have tablet computers or standard computers where you can see remotely how your house is doing right now. And what is happening here, and what we are particularly proud of, is that the house just gets smarter the longer it is in use. What's going on? It's all the decisions that the house did when to buy and sell electricity are stored in a database. So the house can go and pick up the data from the database and see how the past decisions affected the money saving, and also how it affected the performance of the devices that we have. So the longer you have your house running, the smarter it gets, collects data for analysis them, and see the results So, for example, the next year, when the winter comes, it might give an expectations, what to expect to happen during the winter time. And sure, here is our hardware that we have. This is a representation of the storage of energy that we have right now. We have a connected battery here. So what's going on is the system activates. Yes, the battery is here. The system activates, makes a decision based on the current weather, energy prices, and it decides now it would be the good time to buy. So it activates this charger, which will charge the battery afterwards. In case that you have enough energy, it can use to discharge the battery and power your house, or even sell electricity back to the grid, of course. Also, we have the water tank, which is now just represented here, and this allows us to store energy as heat. So, yes, you can see we have sensors plugged into the computer, and the computer always reads what is the status of the tank based on several sensors that we have here. So we can see how much energy we have in the heat. Then there is going to be a connection that provides how much energy we have in the battery, and pretty much this is how the data are analyzed. And now, Anas, please.
Og der kommer jeg så på banen med vores udstyr for bygningscomputer. Det er egentlig en bygningscomputer, men den er unik ved, at den har et multi-connectbar bussystem, som kan connecte alt, hvad der findes af intelligent busser. Fordi der er ikke rigtig nogen standarder inden for bygningsautomatik, derfor har vi lavet connection i hvert fald til de første 8-10 forskellige busser. Og det gør så, at vi kan connecte til Andreis interface, vi kan connecte til energimåler, vi kan connecte til nettet, og vi kan connecte sensorer og udgangsmoduler. Helt skalerbart. Der er ingen grænser for den der del. Og det er så en fornøjelse at kunne, når de spurgte om et eller andet, så laver vi det bare. Så det bygger altså på en platform, hvor vi også connecter selv brugerinterfacet via XML eller OPC, eller til internettet. Og det er sådan, vi snakker om, at vi har den fulde integration. Ja, det er sådan set.
Og jeg som underviser for de dygtige studerende og samarbejdspartneren Anders og Videncenter for bæredygtig økonomi, der siger, at for ICT Engineering, vi er stolte af det her projekt. Det er noget, der kan udmyndes i noget konkret. Vi har alle aspekter, vi har prototyper, vi har samarbejdspartner med erhvervslivet, vi har samarbejde med huset som sådan. Vi har desværre ikke lige fået alle pengene hjem endnu, men altså, vi håber, vi får råd til at købe nogle tanker og nogle flere sensorer, og så ikke bare kører som et lille projekt i en enkelt hus, men måske også få lov til at lave en field trial, sådan at vi prøver på et husinstallation, men måske også en virksomhed, hvor det har meget større energiforbrug, så at der er for eksempel en DONG eller andre, de kan sige, at på den tidspunkt, hvor der er overkapacitet på netværket, så kan man sende energi ud via et smart net, og det er det, vi er på vej ind imod. Så vi skal lige have lidt mere udstyr, og det håber jeg, at det måske kan hjælpe lidt med. Ellers har vi fra idé, prototype, af proof of concept, som jo rent faktisk proof of concept, som alle har kørt her i august måned på det her projekt, og det fungerer fint. Og så er facilities og open course, for det er derfor, vi bliver Christensen med i dag, som optager det på jer. Tak for det.